Today's class, we're going to learn about multiplying and dividing a polynomial by a constant. And then the second part of the lesson, we're going to look at the same idea, multiplying and dividing, but a polynomial by a monomial. So a little bit different. So we're going to work with a polynomial right here and a constant, meaning the other term is just a number. Okay, so if we look at the first page of our notes here, we can see here what is being shown here. How does this diagram model the product 3 times 25? So we have the 3 over here, 25 across the top. We have 3 groups of 25, so you could say it's like 75. 3 times 20, 3 times 5 would also give you 75 as a product. So that's called the distributive property. The 3 applies to all the pieces that you could break that 25 up into as you move across. So we're going to jump right in. I'm going to skip through a bunch of pages here. Those investigate pages that we usually do, but we're going to skip over those today so that we can get going a little faster, okay? Okay, so we can see here, I'm just going to try to make this a little bit bigger for you. You can see here, so it says the expression 4 times 3x is a product statement if it represents the product of the constant something and the monomial something. So if we look at this, our constant is the number part, so the 4. Oops, I have to turn my pen off. Just a second. How do I do that? Okay, so I'm back. Okay, so I'm looking at my constant is 4, my monomial's 3x. Okay, so it represents the product of 4 and 3x. We can model the product as 4 rows of 3 x tiles. Okay, so we have 1, 2, 3, 4 rows. And here across the top, we can see how we're seeing our 3x. X plus x plus x is 3x. So if we counted up all those tiles, we'd see there were 4 here, 4 here, 4 here, and they're all x's. So 4 plus 4 plus 4 would give us 12 x's, right? 12 x tiles. It says down here, we can also model it as a rectangle. So we see the rectangle here with dimensions of something and something. What are those somethings going to be? We have our 4, just like we saw up here. There's the 1, 2, 3, 4. Here's our 4. So then if we look here, that's x. So this is going to be 3x. Okay, so 4 times 3x. Really, we're just looking at our coefficient and our constant. So 4 times 3 is 12, and it's 12 x's. And there we go. So 4 times negative 3x, almost the same thing, except now we have a negative number. That's okay. We're not bothered by that. We can model the product as similar, except now we have the red tiles, right? So our negative side of our tiles, we have the 3x's here and the 4. So 4 times minus 3x gives us minus 3, minus 3x, minus 3x, minus 3x, which is minus 12x. And another way to look at this, which I find more confusing, but maybe you will like it, is if we say minus 4 times 3x is the opposite of 4 times 3x. So if you show 4 times 3x like this, and then flip everything over to show the opposite, that would also be a way of modeling that. So see how we just changed it. So again, the same idea. We could just multiply the coefficient of x with that negative 4. 4 times 3 is 12, and there's a negative sign, so it's negative 12x. Easy peasy. All right, so if we were going to do these examples, again, if we look at that first one, we have 3, and then our polynomial is minus 2m plus 4. We're going to do 3 times minus 2. Okay, so we could show it with our algebra tiles. So we have minus 2m plus 4 in each row. as we go across the row, you have minus m, 1, 1, 1, 1. So each row is showing you minus 2m plus 4, and we have 3 of those rows. That's how we're multiplying it by the 3. So if we counted all that up, we'd end up with 3 times minus 2m plus 4. So 3 times minus 2 is minus 6, and those are m's. And then 3 times 4 is 12. So we have minus 6m plus 12, and we can see those here. Minus 6m's, they're there, and then the plus 12 are over here. If we look at the second question, we have negative 2 times, here's the polynomial, negative n squared plus 2n minus 1. So here we could show each one of these rows, look, it's negative n squared plus 2n minus 1. And we want to do that 2 times. So here it is, 1 time, 2 times. Because it's negative, this is that thing where they're going to flip it all over. So flip everything over, and then that's going to be the solution. So 2n squared minus 4n plus 2. And there it is right there. If we wanted to do it a different way, so method 2, we don't have to do the thing with the tiles. We could just look at the coefficients of these numbers. Okay, so we have a 3 and a minus 2, and a 3 and a 4. So we have to apply that 3 to every part of here. So we have 3 times minus 2m, and then 3 times 4. We're just breaking that up into 2 pieces and being careful with our negative sign, putting them over here. So we have 3 times minus 2 is minus 6m. And then 3 times 4 is 12, and that's just 12, no m or anything. And you can see down here, same idea. With division, it's the same idea. You start with your polynomial, and then you're going to divide every part of that polynomial by whatever the number is that you're dividing by. So here you were going to divide by 4. 4s squared minus 8 divided by 4. You could do it with tiles and show the 4s squared minus 8. And arrange it into 4 rows, so whatever you're dividing by. And then look and see what's in each row. Another way you can do that is just to look at those coefficients. I'm going to skip past this for a minute. Just to look at those coefficients. We have 4s squared minus 8. I'm going to just take the 4s squared by itself over here, and then the minus 8 by itself over here, and I'm going to divide both of them by minus 4, or just by 4, not minus 4, sorry. So we have 4s squared divided by 4. 4 divided by 4 is 1. So we have just s squared, right? And then minus 8 divided by 4 is negative 2. So that's how we get this answer down. Okay, and we'll skip through these guys.